There are a couple ways to do this problem. So I have the sine of f of x plus 6y plus z equals 0, and I want to find partial with respect to x and partial with respect to y of z. So let's define z implicitly, and one way I can do this is using implicit differentiation. I can take the derivative of both sides with respect to x and keep in the back of my mind that z is a function of x and y. So if this is true, I'm going to have, for instance, my partial derivative of this sine of 5x plus 6y plus z is, well, the partial derivative of 0 is 0. So this is going to be a cosine of 5x plus 6y plus z times, and then partial with respect to x here, I'm going to have a 5 plus 0 plus partial z with respect to x is 0. And the cosine here isn't going to be 0 when the sine is 0. So if this part's non-zero, I'm just going to have 5 plus partial z with respect to x equals 0, which means in turn that partial z with respect to x is negative 5. And then likewise, we can do the same thing for y. And we're going to have partial with respect to y of sine 5x plus 6y plus z is 0. And this is going to give us, again, we're going to have taking the derivative, cosine 5x plus 6y plus z times, then 0 plus 6 plus partial z with respect to y equals 0. So this is going to be 6 plus partial z with respect to y equals 0, which means that partial z with respect to y is negative 6. If we wanted to, we could have done this another way, because I could say if sine of 5x plus 6y plus z equals 0, then 5x plus 6y plus z is some integer multiple of pi. So I could write z equals, or n pi, minus 5x minus 6y, and then it's obvious partial z with respect to x is negative 5, and partial z with respect to y is negative 6. So either way, this is not a difficult problem.